information, Adrian Arul is our regional manager for Rockfall sector. He is responsible for the regional markets such as the market of Hong Kong, Japan, um, Australia, New Zealand, and others in the region. When we started the Rockfall Solutions maybe more than 5 years ago, Adrian Arul was very instrumental and very helpful for us in starting the business. In fact, Adrian was the one who trained our team, and he was the one who initially provided the design and the installation assistance from Malaysia. Okay, so as far as Maccaferri is concerned, Adrian is our regional expert when it comes to rockfall and debris flow barrier because of the years of experience he has on this solution. Okay, so just for some ground rules, I just would like to request everyone to please mute their phone so that Adrian rule can be heard by everyone. This is supposed to be an interactive training. So at any point in time, if you need some clarification, you can interrupt Adrian and ask questions. However, for some questions which you may think will take a lot of time, we will set at the end of the presentation a Q&A session. So we can discuss more of some topics which you need more information from Adrian. Okay, so without further ado, I'd like to turn you over to Mr. Engineer Adrian Arul. Adrian, you may proceed if you're ready.
Right, thank you, Andrew, for the introduction. First, let me put up my slides. Okay, can everybody hear me? Good morning to you.
Yes, good morning.
Yes, okay, good morning. Okay, now I know you can hear me. All right, as Andrew mentioned, today I'll be presenting a Rockfall training. Some of you, this may be a refresher course. Some of you may be new to this. But the topic today is purely about installation of rockfall and debris flow barrier. Firstly, Andrew introduced me, but I'll just say a few words about myself. My name is Adrian Arul and I'm from Malaysia. I've been with Maccaferri for the past 10 years in the rockfall sector. Today, as mentioned earlier, we'll be discussing about the installation of rockfall barriers and debris flow barriers. I hope you will enjoy the presentation. Feel free to ask any questions. I will answer them to the best of my knowledge. Firstly, what is, just some introduction, what is the motivation for us to install rockfall and debris flow barriers? Basically, mainly it's to protect infrastructures, right? Especially in hilly areas such as highways, railways, and also urban areas, urban development. The purpose of rockfall and debris flow is to mitigate the risk. And in protecting the transport and urban infrastructure assets, right? If we use debris flow and rockfall barriers, basically it is a kit, so you will have minimal disruption to your operations with this kind of solution. And this kind of solution provides a low capital cost expenditure compared to other rockfall solutions, especially during construction. Now, I think many of us may not have a first-hand experience with the rockfall incidents. So I thought I'd just give you a video of an online experience of a rockfall experience. So this is actually a video in Taiwan. You see, this is a rockfall incident. This is a near miss. Luckily, nobody got hurt in this incident. This area is actually prone to rockfall. The second one is about debris flow. This is a basic structure of a debris flow. You can see in a debris flow, you have what we call the frontal head, this part here, right? Usually this part here is made out of coarse and bouldery rocks or material. And as at the tail end, as you go towards the tail end, you will find that the material is more finer, right, and more liquefied. This is a YouTube video that shows how debris flow looks like. So there is a couple of things that I want to highlight before I start my presentation. Presentation is based on the following premise. Firstly, we cover the best practices, the installation of rockfall barrier, which applies, number one, to only Maccaferri rockfall barriers. Number two, there are different type of Maccaferri barriers. That means there's different energy level. We have an energy level from, we have barriers from energy level 100 kilojoule, which is our lowest, right up to 8,600 kilojoules. Each barrier has a different makeup, has a different components. So it's not possible to just go one by one because there's so many components and makeup of the barriers. But we can always refer to our installation manual for a guide on how to install, right? So the installation recommendation presented today is basically a general concept and based on experience that we have had all throughout these years. Another thing is there is no general site. Every site is unique. So there might be special circumstances that you encounter at site, and this can be dealt with on a case-to-case basis. When you need our help, please free to contact us. We provide free site assistance and advice whenever you need. We can send our guys to the site to help you and give you guidance during installation. Another important premise is any local and national law or regulation requirements, especially with regards to safety, right of way, this shall take precedence over our installation manual. So when you install, the installation manual is a guide, but you should also check with the engineer and also take extra precautions with regards to safety, right of way, etc. Now, the first thing I would like to emphasize on is safety during installation. There are a lot of safety issues, right? I've just taken some important ones that I think that usually encountered at site. Number one is that we always should have a qualified person supervising the installation. At least the person should be well read of the installation manual, right? That is that will be given to on request to the installers. And please read this carefully. Take cognizance of all the whole points, all the important points that have been highlighted in the installation manual. Number two, you must take additional extra precaution, especially during tensioning and installation of ropes. Okay, this is a very important part of the installation. And please make sure that no persons that are not involved in the tensioning works within the hazard area. Number three is removal of tension parts shall be always avoided. For example, you have ropes and you are tensioning the ropes and then you are installing the wire rope grips on the ropes. Once you install it, please do not try to open it again. That is a very dangerous thing to do, right? So always try to get the job done right the first time, right? Another thing, if possible, usually you will install your rockfall barrier near the toe of the slope, somewhere near the toe of the slope, right? So sometimes potential hazards at the top of the slope, at the crest of the slope, is not visible from the bottom of the slope. So I advise if you have drones, please do a fly through, right? So that you may know that if there's any dangerous rocks or boulders or outcrops at the top, because during installation, this may come down. So if you do a drone fly through, that may give you a visual assessment of any hazards at the top of the slope. Now we go into the topic of the day. Number one is the installation of the rockfall barrier. Basically, the general configuration of a barrier is as shown. Right? You have support cables, right? Right, you have longitudinal cables, upper longitudinal cables, lower cables. You have lateral cables, and also in some barriers you have you don't have this upslope cables. We have two kinds of barriers that don't have these upslope cables, which is our 100 kilojoule barrier and our which is our RB 100 UAF model, and 500 kilojoule barrier, which is our RMC 050 ICAT/2 model. These two models does not have the upslope racing cables, as I'm showing here. But the rest of the barriers from our 1000 kilojoule right up to our 8600 kilojoule, they have these upslope cables and anchors. Next, all barriers will have posts, right? All rockfall barriers will have posts, and all rockfall barriers will have what we call interception screen or the nets. This also varies from rockfall barriers to rockfall barriers for different energy level. A lower energy level, our 100 kilojoule will use just wire mesh. Then we have our 500 kilojoule and our 750 kilojoule. They use HEA panel, which is a wire rope mesh. We usually use the wire rope mesh together with a wire mesh. Okay. Then the higher energy levels, use ring net panels. We use the wire mesh together with the ring net panels. Then the energy dissipators. This energy dissipator is important because during dynamic impact, your wire ropes will be having shock loads. So we need to dissipate the energy, right? So that the shock loads do not break the wire ropes. For low energy, 100 kilojoule, there's no energy dissipators. But above 100 kilojoules, all the barriers have energy dissipators. This is a very important component of the barrier. And care should be taken during handling at site, right? Because sometimes people just throw it to the side, they don't take care of it, and they may damage these energy dissipators, right? The energy dissipators, if bent, or if there is a kink in the tube, it might not work as it's supposed to. So this particular component is a very important component in our barrier. Now, there's two major part of work that you need to pay attention to when you are installing. One generally is the setting out of the anchor position and the alignment of the barriers, the post position and the anchor position. Another one is the installation of all the components, the post, the base plate, the ring nets, the ropes, and so on. For the setting out, it's basically survey work, right? And you have to, these are the tools that you need. Basically, you need a measuring tape, preferably 30 meters to 50 meters, right? A hammer, a spray can, preferably red, so it's quite visible. Wooden packs to mark out all the anchor positions, the post positions at site, our installation manual, and also the engineer's construction drawing. Okay? The installation manual is a general guide. The construction drawing may give you more details, the length of the anchor that you're supposed to drill and so on. For installation work, these are the basic tools you need. You need a ratchet wrench. If possible, you can also use the power wrench, okay, a socket wrench. Torque wrenches, right? This is for tightening the U-clamps, right? Cable cutter, disc cutter, pliers, inclinometer. Inclinometer is to, when you are installing your post, if your post is inclined, so you want to adjust the angle of the post with respect to the vertical, right? So you need to have an inclinometer. Adhesive tape. This tape, usually why we need it is especially when you are cutting wire ropes. When you're cutting wire ropes with a cutter or disc cutter, it's advisable to wrap the adhesive tape at the point that you are cutting, right? Before you cut the wire ropes. If you don't have this adhesive tape, when you cut, the wires will dislodge. It comes out like a flower, it blooms up like a flower, right? So when you put this adhesive tape, or you can also use a wire, right? Small thin wire, okay? So when you cut, so the end of the wire ropes are intact, right? Then you need chain hoist to hoist up materials, and also the ring net, cable turnbuckles, traction lifting device. You can also have cable winch, especially when you are lifting up posts and heavy materials that it's not humanly possible to be carried up. You can use cable wrench and ladders, right, to fix, right? I will show you some videos later about some installation. Other than that, another issue that sometimes we face is because we usually work in remote places. Unloading material could be a problem. Sometimes you can use lorry crane to transport your materials from your factory or from your site office to the site, or your storage area to the site. You can use a lorry crane to offload the packages, right? You can use a crane sometimes to lift posts and heavy materials if it is within the reach of the crane. Some used excavators, especially in terrain where they don't have proper roads and access, and they don't have the facility of crane, a lorry crane to lift up things. They use excavators. In the last photo here, you see that sometimes they don't have excavators, and because it's a very remote place, right? You can have this kind of fork attachments, right, to your backhoe or something like that. It will help you to offload posts from the lorry, something like that. This could be an option for unloading material. Now, basically, these are the steps that you need to know when you are installing rockfall barrier. Number one, most important, is to verify the feasibility of the design. Usually, the drawings are based on desk work, right? The engineers at the site, they base on topography, and to the best of their ability, they do the alignment of the barrier on the plan. But this has to be verified by the installer. The installer has to verify whether whatever is on the plan is feasible, and you need to give the feedback to the engineer. And the engineer, if you need any help from us, please feel free to contact us. We are most happy to help you out. Right. The first thing about the barrier is the alignment. This is a very important part of installation of the barrier. The second step is the anchors. Once you have set out the anchor positions and the post positions, then you do the installation of the anchors. Then you do the positioning of the base plate. After the base plate, you install the post. Then you can install the ropes, the support ropes. Then you install the nets, the interception screen, and then you do all the connections, the U-clamp, the U-shackle, and all the accessories. Now, I'm just going to show you a video. Here of the basic steps that I've mentioned in the previous slides. This is our partner in Hong Kong. We have done a video with them on the installation, just to show and educate on the steps to be taken during installation. This is for a 3,000 kilojoule barrier. So the first step is to do the alignment, mark all the positions of the posts and the anchors. Usually the post-to-post spacing is about 10 meters. This is the grouting and drilling part. They are using a down-the-hole hammer, percussion, and yeah. This is installing the anchors and grouting anchors. Then we have the construction of the plinth. Then because of the site condition, they need to use a winch transport posts, base plates, material. This is the installation of the post. And what they are installing is the upslope cables. Once they slot in the post, they slot in the boards. Then they use the upslope racing cables to lift the post to position. This is an inclinometer to ensure that you have the correct inclination on your post. This is called the turnbuckle device. And they secure the fishing cables using the U-clamps or wire rope grips. This is the energy dissipating device. This is fixing the lower cables. Next, we look at the installation of the ring net, the wire mesh. So once all the ropes are secured, then they start lifting the ring net. This is the lateral cable. This cable is the side of the net, last panel. This is a picture overview of the site that is completely installed. Okay, hope you enjoyed the video. Next, I would like to talk about the alignment of the barrier. First, we must note that the alignment of a barrier is a 3D problem. So attention must be paid on respect to the planned direction of the alignment, the elevation, and also the lateral and side direction, especially on the post inclination. Now, basically, you will have three kinds of alignment. You will have the straight alignment, which is just basically a straight line. Then you may have what we call a concave alignment. That means the center or the intermediate post moves towards the upslope side, towards the mountain side, right? Which is shown in these yellow dotted lines. Or you will have the convex alignment. Convex alignment is this red dotted line where the intermediate post moves downwards towards the valley. The best alignment is try to get it straight or concave. For designers, if you can avoid convex alignments, please avoid convex alignment. I will explain in my slides later some of the reasons why why we do not prefer convex alignment. Now, basically, in alignment of barriers, you will have these 5 general scenarios. First thing is you will have to set up your lateral or intermediate posts. So the posts will have lateral and upslope ropes and anchors. The positions are all given in the Maccaferri installation manual. So for different types of rockfall barriers, so you can refer to them, right? Second scenario is when you have what I said, the convex alignment. When your post moves down slope side, that means towards the valley side, right? When you have this kind of condition, you have to put an extra cable here, anchor at the back with what we call a downslope bracing cable, right, to support the post. Third scenario is you may have a very long barrier, straight length, long barrier. And in that may be an installation problem because you have very heavy ropes. You are not able to pull, say you have a barrier, say 80 meters, 90 meters, and you are not able to install the rope from one end to the other end. So what we can do is we have what we call a shed post detail, right? So we can use this kind of shed post detail to break the continuous alignment for ease of installation. Next scenario is case 4, where you have a concave alignment. But the concave alignment, the offset, because the alignment changes direction. When it changes direction about 30 to 40 degrees, right, in this limit, around this limit, then you may need to have upslope bracing cables because these adjacent ropes may be opened up too much, right? That I will explain later in detail later also. And sometimes instead of one downslope bracing cable, we may opt to have 2 downslope bracing cable in cases where alignment changes more than 20 degrees, right? Or you don't have enough downslope distance between the post and a proper position to anchor at the downslope position, then you can opt to shorten the distance between the post and the anchors. We may need to have 2. And also for high energy barriers, when the energy, high energy barrier, say 5,000 kilojoule, 8,600 kilojoule, a single upslope bracing cable may not be sufficient. Then you may need to use two, right? This can be designed. Now, for case one, this one here, right? The plan looks like this, right? You have the post here, and then this yellow circle, the yellow circles here are the upslope bracing cables, and the red circles here are the lateral anchors. Okay, the yellow is the upslope anchors, and the red is the downslope anchors. You can see generally the distance between the anchors, upslope anchors, is about 10 meters. But the distance, offset distance from the upslope anchor to the alignment, right, it varies. It's shown here as dm. The distance between the post and the lateral anchors, it varies. Yeah. These are dependent on the height of the post. When the post height differs, then your dm and your dl may vary, right? So this dimensions is given for the RB 1500, our 1500 kilojoule. But these values will vary from barrier to barrier, because different barriers may have different post heights. So these values will vary from barrier to barrier. So you need to look into these values in our installation manual. Now, when your alignment changes, right, in convex alignment, that means your center or your intermediate post moves downwards. If you can see, the alignment changes from this direction and then goes upwards. And this is what we call the offset angle. If it's between 15 to 20 degrees offset angle, then you must put a downslope bracing cable. We recommend a minimum of 3 meters, right? Why is this important? Because when you have this kind of alignment, your ropes, these ropes and these ropes, upon impact will tension. When they tension, they will induce a resultant force that will move this post upwards. So we need a downslope cable to counter this upward movement. This is the other scenario that I said, the shed post, when we have very long alignment. Alignment around 60 meters to 100 meters. 60 meters for higher energy barriers, and 100 meters you can, one continuous section you can do without break for low energy barriers, like our 100 kilojoule and so forth, then there's no problem. We have installed up to 100 meters without any shed post. But as the energy level goes higher, then the cables become heavier. So the shed post might be required around 60, 70 meters for higher barriers. It also depends on a lot of other factors, like how the slope morphology, the topography, and so on, right? So you can break continuous alignment by using a shed post detail. The shed post detail will is basically a post, and you have this red line. That means the longitudinal cables coming from the left, right, will be anchored in the right side of the post, right, and the right longitudinal cable will be anchored at the the right longitudinal cable will be anchored at the left side, and the left longitudinal cable will be anchored at the right side, right? So this is basically a schematic of how a shed post looks like. Now, when you have conditions when the offset distance in a concave alignment, that means the intermediate post moves upwards, right? You can see if it is very the offset angle is very big, around 30 to 40 degrees. When the alignment goes like this, these two, this and this, you can see it opens up too much. Opens up too much, right? So because it opens up too much, you don't have any resistance on the upslope side. So we advise that you install an upslope bracing cable with an anchor in order to give some resistance in the upslope side if the alignment is too big. Right? So when you have very big offset angles around 30 to 40 degrees, we advise additional upslope bracing cable. Okay. Now, when you use two downslope bracing cable, as mentioned in the earlier slides, as you can see, when these orange arrows, when there's an impact, the cables will tension. When the cables tension, you have a resulting force shown in this red arrow. When this resulting force comes into play, it will pull this post upwards. So in order to counter this, we need a resultant force in this green arrow going downwards in order to maintain stability of the post. So we have two anchors like this. These anchors and this downslope bracing cable will be provided. It will provide counterbalance for the post. So minimum 3 meters, or this can be designed. Depend on the site condition, we can design what is the length that we need. Now, installation of anchors. We usually, for the upslope and lateral anchors, we use the cable anchors. We call them flexible cable anchors. We call them ICAF 44T. They are made of spiral ropes, right? This ropes is different from the normal ropes that you see, which is called the stranded ropes, right? These are more rigid and they have a higher minimum breaking load as compared to normal ropes, right? So this kind of anchors are installed in the upslope, the lateral, and downslope positions. For the plates, we provide bar anchors, right? This kind of the normal bar. Usually we provide fully threaded anchors. So the anchor comes with a thread for the whole length of the bar. So at any time, if you cut in any position, you still can install the nut, right? Okay, you don't have to thread or put it. So that is why we use a fully threaded bar, right? Now, plinths are not required. This kind of plinths are not required on hard rock. It just suffices to just use some non-shrink grout to fill up any gaps between the plate and the rock, right? On hard rocks, you don't need to have plinths. But soil or weathered rock condition, we recommend you use plinths because later there may be some scouring underneath the plate, right? For the installation of posts, you can use cranes or helicopters, and sometimes it's not possible. They hoist the posts and the base plates up by hand. But the first thing is before you can install your post, it is important that you position your base plates properly, right? So This is a schematic showing how to orientate your base plate on the plan view. So if you have a change of alignment like this, okay, your base plate must be perpendicular to the alignment line. But when you have a difference in the alignment, right, you always have to make sure that your base plate, right, bisects the angle. That means if, like you see in this, you have to orientate your base plate so that the angle between the base plate, right, to the alignment here is same on the right and on the left. See the wrong way to align or orientate your base plates, right? Number two, next is for the base plates and the poles, is that most likely in sites you will have a difference in elevation. We advise that you try to avoid positioning the post with a difference of elevation not more than 0.5 meters when the post is 10 meters distance. Right? There are two main factors for this, why we say the two main reasons. One is when you have this kind of excessive elevation difference, you can see that this point from here, from this corner to this corner is actually longer than from this corner to this corner, right? So the red arrow shows a longer distance compared to the green arrow. When you have a longer distance, you are stretching the net. When you stretch the net in this way, you have more stress here compared to this green side. You have less stress because it is not stretched as much as the red arrow. So you have additional stress here, but a lower stress here. So that is why we try to, as best as possible, limit the difference between the posts to 0.5 meters. Right? Another reason is your net comes in a rectangular shape, right? So when the net comes in a rectangular shape, the ring net is more flexible. But for the HEA panel, you must be careful. The HEA panel is the wire rope mesh, right? It is fixed, right? So if this distance is 10, this distance is 10, this distance cannot be 10. It has to be more than 10, right? Because it's on the slope, right? So if you install a barrier, your post at a 10-meter distance, right? Then this net may not fit because this one becomes more than 10 meters, right? So there's two problems. One is in terms of the stress distribution. Another one is the dimensioning of the barrier. So what do we do? So basically, if in case the net is 10 meter, right? Okay, the post spacing is dependent on the difference in elevation, this H here, and all difference elevation, and also the post height. The post height and the difference elevation will affect the post distance, effective post distance, right? If this is higher, then the post effective distance is different because the net stretched in a different direction and longer. So this is a graph that gives, okay, effective post distance versus the elevation for if there's a zero difference in elevation, then you can use 10 meters. But if there's a slight difference, you can see that the effective distance of the post reduces, right? Until 0.5 meters, okay, we have a tolerance. You don't need to change the post spacing. But once it goes higher, 1 meter, 1.5 to meter, the post spacing may be need to be brought closer for a 10-meter net length. Right? Now, another important aspect of installation that you may need to pay attention to is the installation of the post in the inclination of the post, right? Phi here signifies the inclination of the post, and it is dependent on the slope. The higher the slope angle, all right, you will have to bring the post forward, okay? The inclination is less, right? Forward towards the upslope direction as the slope inclination increases, right? Next, you must be very careful also how you align. The inclination, you must try to incline the post consistently. You cannot have different inclination of different posts, then you will have a warped barrier. That means a distorted barrier, as you can see in this picture. When this happens, the stress distribution is affected. So as far as possible, try to have your post all the same inclination. Another important thing is when you do the upslope bracing cable. You see, if you have enough room at the upslope direction, then you can anchor your upslope bracing cable in accordance to the installation manual, which is perfect, right? But in case you don't have enough spacing, say you have a slope that is very nearby and you cannot achieve installing this anchor right at the ground. So you can install the anchor at the slope area, but there are several conditions that you need to follow. Number one is you need to have a minimum 3-meter distance, right? So you try to adjust your post so that you have a 3 meters distance. And also what is important is the angle. We can accept an angle between 55 to 85, but always please follow the installation manual as strictly as possible, right? This angle is important because this angle governs the distribution of the forces in the upslope bracing cable. Next, when you install your ring net or your HEA panel, right, or your nets, usually they are for the higher energy level and from 5, and also the intermediate energy level from 500 kilojoule to right up to 8,600 kilojoule. Okay, we will need 2 layers. One layer is the DT mesh, right? Is wire mesh, and you could have a ring net or HEA. Okay, you have to install the DT mesh, the wire mesh, on the upslope side, all right, towards the mountain side, and the ring net or HEA panel towards the downslope side, all right? Okay, this is the way that you should install your net. You have this kind of situation. So there is 2 positions here, right? And you can see there's a gap below the barrier. So what do we do? We can do what we call a skirting detail. We call this a skirting detail. That is to install additional ring net or nets at the bottom, okay? And then use some anchors to anchor these positions. And this can be connected to the lateral anchors, or you can have additional anchors at the side. Because when the rock rolls, and if there's a gap here, it can pass through the gap below the barrier. The connection. The connection is very important, okay? And I'll be talking about specifically on the wire rope clips. This is basically the makeup of a wire rope clip. You have this component here is called a U-bolt, and this component here is called a saddle. Right? Okay. So when you are installing the U clamps on a wire rope, okay, on a wire rope you have what we call the live end and the dead end. The dead end is where the wire rope is terminated, and the live end is a continuous one that is connected to another anchor or to another part of the barrier. Right? This is the longer part. The dead end is the shorter part. Right? So please remember this. Never saddle a dead horse. In this case, the dead end is the dead horse, right? So this saddle cannot be on top of the dead end. It has to go to the bottom here on top of the live end. So you can remember this. Never saddle a dead horse. So the saddle is always have to be on the live end. And also you have to make sure that your position is all in the same direction. You cannot install the clamps one saddle on the live direction, one saddle on the dead direction. This is not acceptable. And also you must need to know several things, as you can share. For different cables, there are different types of U-clamps, right? Okay. And each U-clamp, right, the distance between each U-clamp, there is a rule saying what is the distance between different types of U-clamp. And also the torque requirement. The torque requirement is how tight you can screw on this nut, right? So, and how many numbers of U-clamps you need to install. These are all specified in our installation manual, so please follow them strictly because this U-clamp is the one that is holding the wire ropes. Once this gives way, your whole net will come down. So this is a very important thing to remember. If we go on to the installation of channelized debris flow, basically whatever I've told you for the rockfall applies to the debris flow. All the alignment part is a little bit different, okay? But basically the installation of the post, the base plate, the anchors, the wire rope clips, mostly both are more or less the same, right? This is actually a picture from Philippines. This is maybe later Andrew can tell. If I'm not mistaken, it's a project in Dinagat in the Philippines, right?
I guess it's in Romblon. I might be. Bai, can you confirm with me? Is this the one with the mortar builders? Junmar
Yes,
is here.
with Junmar. Yes, yes.
So the installer is right here, Adrian.
Yeah,
Junmar.
yeah, very good job. Congratulations to you. You did a very good job. You can see that from this picture, the basic components of a debris flow barrier. You will have longitudinal cables, right? Okay. They go, if this is the direction of the debris, they go at the downslope side or at the back of the ring nets. The ring nets are placed on the upslope side, right? So basically you have the longitudinal cables. This post is optional. Some designs you have the post, some design you don't have the post. The post is usually used when you have very long debris flow barriers because there is a limitation. Usually it depends on the design, but usually less than about 15 meters post spacing. But it depends on the design as well, because some design, because of the energy of the debris that's coming down, we may need to make the post spacing closer, right? So this is another component, the post. And then the cable anchors, right? And then we have what we call the lateral cables, okay? Then we have the U-shackles. U-shackles is to connect the ring nets to the longitudinal cables. This is basically the steps. First thing is you have to install your anchors. All right. I think as experienced installers, you know the procedures, but I'm just going on for those who are not very familiar with. You have to install the anchors, right? And then after that, you install your longitudinal cables, right? We provide installation manuals to show you how to do this, right? Be careful when you are installing your longitudinal cables because in debris flow, the longitudinal cable comes attached with a energy dissipator, with a brake. So when you are tensioning, don't tension too much because you will activate the energy dissipator. Don't tension too much. As long as it is taut, it is tight enough, it's good. Right? Always during tensioning the ropes, it's better to have one guy watching the EDD. One guy is tensioning the ropes. Another guy should watch if there is any movement on the energy dissipating device. All right? So basically, this is the setup. Then you put the ring net, and we use shackles, or sometimes we can weave the anchors through the ring net. So you can use the shackles to connect the ring net, or you can do the horizontal ropes. Then this is a picture, completed project. This is actually a debris flow barrier in New Zealand at a point called Starvation Point in the southern island in New Zealand. So thank you very much and selamat. I think I am a little bit more than my time. I took more than 10 minutes. It's supposed to be 1 hour. So I give it back to Andrew.
Okay, thank you, Adrian. It was, I think, a very interesting presentation. So now the floor is open for your questions. Junmar made a comment that they were the ones who installed the debris flow barrier. In fact, Jun, we are always highlighting your project whenever we make a presentation. So it was a very good installation on your part.
Yeah, thank you also, sir, for the assistance of the sales and technical team. It won't be possible without your assistance.
Do you have question, June?
So far it is clearly defined the technical terms and the procedures, but can we secure a copy of the presentation so that we can uh, we can review much of the terms and specs if it is allowed.
Yes, we will send you, June, after this presentation. We will send everyone a copy.
Ah, it's a very good presentation that it will enrich our knowledge for the system and for further design of your products.
Thank you, June. Any questions from our friends? Maybe our friends in DPWH? Actually, we have an ongoing installation of debris flow barrier from Sir Boyet. Sir Boyet, do you have questions? Okay, okay. So okay, Sir Boyet. So we will be looking forward to your to the pictures as well of your installation.
So if nobody is asking me any question, can I ask somebody a question?
Go ahead, Adrian.
Yeah, June. June, you are the installer, right?
Yes, yes, yes,
Yeah.
yes.
We always like to have a dialogue because we also learn from the contractors the problems they face, so that we can improve ourselves as well, right? Improve how we service our customers, how we guide installers. Could you share what is the main problem that you faced when you are installing the debris flow?
Okay. Thank you for that. One of the main problems that we encountered is that the quality of the soil and because as you can see in the picture, it is like a sandy one, and we cannot anchor it properly on the sides of the channel. That is why it is very hard for us to make it what do you call this, to make a hard part, or the hard part to anchor our cables. So what we did is that we put additional, as you can see in the picture, we put additional concrete in the sides. Concrete, we reinforce it, reinforce concrete, and then we put additional uh, anchors. We drilled a lot so that we can have a fixed foundation for the for the debris flow. That is one of our, every time we excavate the the soil, or the sandy soil goes what do you call this, collapse every time. So it helps a lot, the reinforced concrete that we put it as an additional reinforcement for the foundation. Hello? Yes?
Thank you,
Yeah,
Sir
thank you,
June.
June. Yeah.
Thank you, sir. Good to hear.
Adrian.
Yeah, sure.
Hi, Adrian. Michael here from the technical team.
Yes, Michael.
Um, um, in relation to our topic, because we are in the question of foundation. Um, some of our, I do have a question. In some of our um, manuals, there are two options for the position or the orientation of our threaded rods. Maybe our clients would encounter this in the future. One is perpendicular, or the one is perpendicular to our base plate, and another option is the one threaded rod on facing the upslope side is angled. So what are the advantages of each options, and how do it affect installation? Because I know from some of our contractors, they have hard time of installing the base plate if it has an angled orientation on the upslope, the threaded rod.
Okay.
So so so
Okay. Usually, in my experience, right, we install perpendicular to the anchors, right?
yeah.
If
Agree.
I mean, perpendicular to the plate, right? One is if we have very good foundation, right? Okay. Number two is when you have problems with the inclination of the bars, you don't necessarily need to connect the bars directly to the base plate, right? What you can do is, because usually in soft soil we have a plinth, so we can terminate it at the plinth, right, inside the plinth, and then we can use bars to connect the base plate to the plinth, right? So
Yeah,
you,
understood.
because it is very difficult to get the inclined bar right into the hole of the base plate. right? So you can terminate the bars in the plinth, but usually the inclined one is usually I recommend it for soft soil condition. But if you because there is a lot of lateral movement of the soil, easier compared to a rock, right? If in fact for rock you don't need a plinth, as I said, because some guys what they do is they build a plinth on the rock. The rock is already hard enough, and you can drill directly straight into the rock, right?
Yes, understood, understood.
Okay.
So basically, the angled one is for the soft soil, and the one that is perpendicular, or the ones shown in the presentation, those are for hard surfaces.
Hard surfaces.
Yeah.
And when we did our full-scale test, mostly when we put the instrumentation at the post, at the base, we see that mostly the force that goes into the plate is compression, right? We compression forces. So and we have some shear, right? So the shear is for that's why we put the inclined anchors. But in quite reasonable rocks and all that, you straight can drill directly straight into the soil, into the ground.
Okay, understood. Note taken. Thanks, Adrian.
Yeah, sure.
Hi, Adrian. There's another question here by Big Tayong. Their project needs soil nailing installation of wire nets and hydro seeding. Any recommendations?
The wire mesh and hydro seed. I didn't get the question. Can you repeat that, please?
I think it's not a barrier. It's installation and active installation, I think.
Uh-huh.
I think it's an active installation.
Okay, then we can use MacMat HS. It's a combination of our steel grid.
But
HR.
Adrian, we're not
Yeah.
marketing here the MacMat HS.
Uh-huh.
They can combine Steel Grid HR30 and MacMat 12.1, I think.
Yeah. They can combine the MacMat, and then they can we can combine the MacMat with the steel grid HR, right? And install on the slopes, and then we can do some hydro seeding, or we can for vegetation growth. What kind of slope is it? Rock or?
I think Sir Big, what kind of slope is there? It's a soil or a rock or combination?
It's a rock, sir. Steps.
Rock.
Yeah, steps
Rock.
of rock.
Okay, but honestly speaking, we can try to do it, because I'm not very sure of the site condition. But if it is rock, most probably you can't get vegetation to grow, right? We can do some trial, because we need to know what is the kind of soil that you need. Right?
Yeah, but the recommendation is about soil nailing, soil, and installation of wire nets, then hydro seeding, because now there is existing some vegetations grown up on that cliff. It's hard rock. It's like basalt.
Okay, we need to look at if it's hard rock. You mean trees or is it grass growing there?
Yes, some shrubs, some wild trees. Not so high. There's shrubs.
Okay. You can see because we need to do some. We need to see because on all cases you can't get vegetation to grow on rock.
Okay.
Maybe there is some topsoil, some soils available there, some layers, so the vegetation. If it's pure rock, usually the trees will grow between the cracks of the rock. The roots grow in the cracks of the rock. But if it's pure rock, but if it's a mixture, then there may be. But usually it's very tough to get vegetation on rock.
Yeah.
Right? Maybe you have patches of rock. Some patches you may have soil, and some patches you may have some rocks. Then
yes, the top layer is highly weathered rock. Some vegetation is growing up, but beneath around 300 mm, this solid rock already.
with solid rock, in my experience, is quite tough to get. Quite tough to get growth of vegetation. But if you have some soil, then it can grow. Maybe we have to look it on a case-by-case basis.
Okay. Thank you, sir.
Adrian, there's another question from Sir Boyet. Do we need to expose the foundation of the bracing cables, as I've seen on the presentation? This is on debris flow barrier.
We have to expose the foundation. I can't hear you clearly, Byron. What did you say?
Then, do we need to expose the foundation of the bracing cable, as I've seen on the presentation? This is on the debris flow barrier issue.
You mean the lateral bracing cable, is it? Let me
I think so. Sir Boyet, morning.
Let me see if we can share the screen.
Sir Boyet.
If it is the lateral bracing cable, yes, it has to be exposed because they are the net. When the debris flow hits the net will be extended, and the lateral side will move inward. So it needs to the lateral cable at the side needs to be exposed so that it can elongate. If you embed the lateral cable into the concrete, then the cable cannot extend, cannot elongate. When the net goes inward, because as the net elongate towards the downslope side, the side starts to shrink inward. So it has to pull the lateral cables. If the lateral cables is inside the concrete, right, that cannot happen. So it will just break because it's rigid already. Right? So you need to have the lateral cables exposed at the side of for the debris flow barrier.
Thank you.
Hope that answers the question.
Another more questions? If there's none, I think we cover up all your questions for now. Thank you, Adrian. That's very informative presentation. All participants, thank you for joining. Hope it's adapted to your learning. For inquiries, you can email us directly. Thank you. Thank you very much.
Thank you all. Selamat po. Stay home. Stay safe. Thank you very much.
Thank you. Thank you.